Assalamualaikum and hi everyone. In this video, we are going to discuss pre-lab experiment 3, determination of the molar mass of a metal. We are going to use back titration in this experiment. So, the first question is, what is back titration? Okay, back titration is a type of indirect titration as opposed to the direct titration which we usually use. Direct titration where we have analyte in the conical flask and we titrate it with a titrant directly. But in indirect titration, we have analyte in the conical flask. But before we titrate it with titrant, we reacted some of the analyte with a substance. For example, in this experiment, we have reacted the analyte with metal. So this all analyte in the conical flask. Some of it has reacted with metal, and what's left, analyte left, will then react with titrant. Okay, so to answer this question, titration in which some of the analyte has reacted with another substance before the remaining analyte react with the titrant. Okay, so next, the second question, give one example of alkaline earth metal and write the equation for the reaction between the metal and hydrochloric acid. Alkaline earth metal is metal that is in group 2. So for example, we can choose magnesium, barium, calcium, and so on. Okay, the equation we can write magnesium. For example, I choose magnesium plus HCl. Okay, since magnesium is in group 2, it will carry 2 positive charge, and Cl is Cl minus, so silang charge will get MgCl2 and hydrogen gas H2. So to balance this equation, we have to put coefficient 2 in front of the hydrochloric acid. Okay. Explain briefly how to determine the molar mass of an unknown metal by using back titration method. Okay. We have unknown metal. So let's say the formula is X plus HCl produce HCl2. Since the unknown metal is alkaline earth metal, it is from group 2, so HCl2 plus hydrogen gas. So to balance it, we put 2 in front of the hydrochloric acid. Okay, back titration method, we have analyte in this conical flask. Okay, for example, hydrochloric acid, and the compound in the burette is titrant. For example, we use NaOH. Okay, in back titration method, some of the analyte has reacted with the metal, and only what's left here will react with sodium hydroxide. Okay, to find the number of mole of X, to know its molar mass, first we have to calculate the number of mole of HCl that present in the analyte. I label it as mole HCl on. Okay, and then we can calculate the number of mole of HCl here I call it NHCl left because it is left after the reaction between HCl and the metal. Okay, this is the HCl that is not reacted with the metal, so I call it NHCl left. Okay, we can calculate it by using MAVA over MBVB equal to A over B. Since the hydrochloric acid that is left uh, after the reaction with metal is reacted with NaOH. So we can find from the formula of titration. Okay, so we want to find NHCl left here by taking MAVA. Okay, this is what we want to find, and all the other things we can insert the value. Okay, and then after that we can calculate the number of mole of HCl that react with X by taking mole HCl all minus mole HCl left. Okay, since we have the number of mole of all HCl here and we know the number of mole that react with hydrochloric acid, we can know the number of mole of hydrochloric acid that react with X. Okay, and then we have this equation. Okay, the number of mole of HCl that react with X means we have this number of mole. Okay, for example, if we get the number of mole Y, we can calculate the number of mole of X by using stoichiometry. The ratio is 2 to 1. So, if this here is Y, mole of X is Y divided by 2. And then, after that, we can calculate the molar mass by taking the number of mole, the mass divided by the number of mole of X. Okay. Okay, so for example, let's carry out this data analysis. A 0.2730 gram of unknown metal Y with oxidation number of +2. That means we have equation Y plus HCl produce YCl2 plus H2. And then we put 2 in front of the hydrochloric acid. Since Y have the oxidation number of 2 positive, Cl has Cl minus, so silang charge we have YCl2. Okay, this have 0.2730 gram. Okay, it is completely reacted with 25 ml 0.5 molar excess hydrochloric acid. The remaining solution required, okay, the remaining hydrochloric acid require sodium hydroxide with the volume 4.15 ml and 1 molar to reach equivalence point. So this is the second equation. We have neutralization process. We produce NaCl salt and water. Okay, first question, calculate the number of mole of HCl that react with sodium hydroxide. So if I draw again this, in this conical flask, I have HCl. We first reacted it with Y, and then what's left, we react it with NaOH. Okay, first question, the first question here, we want to calculate this number of mole of HCl. Only what's left after reaction with Y. So here this hydrochloric acid react with NaOH, we have this reaction. Okay, this is neutralization, so we can calculate using neutralization equation formula. Okay, I want to find the number of mole of HCl, so it is MaVa. Ma times Va equal to mole A acid or mole HCl. Okay, molarity base is 1. The volume, turn it to liter, 0.00415. Okay, A and B is the coefficient for acid and base. Okay, so I just write here mole HCl equal to 4.15 times 10 to the power of minus 3 mole. Okay, the second question, number of mole of HCl that reacted with Y. We want to find the number of mole of HCl in this region. So we have to know the number of mole of all HCl. Okay, so mole HCl, all that present in the conical flask, all of it, we can calculate it because we know we have 25 milliliter with concentration 0.5 molar. Okay, and B 0.5, 25 ml turn to liter 0.025. Okay, 0.0125 mole. So mole HCl that react with Y is 0.0125 minus 4.15 times 10 to the power of minus 3. Okay, 8.35 times 10 to the power of minus 3 mole. Okay, then let's calculate the number of mole of Y metal reacted. So this is the second reaction, which is this one. We will have to refer to this equation. Okay. Mole HCl that react with Y is, okay, I'll change it to another color. Okay, this here is 8.35 times 10 to the power of minus 3. So 2 to 1, ratio 2 to 1. So the number of mole of Y is 4.175 times 10 to the power of minus 3 mole. Okay, so this is the number of mole of Y. Okay, then we want to find the molar mass of Y. We have mole equal to mass divided by molar mass. Molar mass, mass divided by mole. The mass of Y is 0.273 divided by 4.175 times 10 to the power of minus 3. So we get 95.39 gram per mole. So you can find which metal that has molar mass the nearest to 65.39 using the periodic table.